Okay, good morning, and we will start with our session, Computer Security Session 3, Cryptographic Tools, Asymmetric Encryption. In the previous classes, at the first one, we talked about a general information about what is integrity, confidentiality, and integrity, availability, and so on, which we know as a CIA traits. However, in the previous class, we had the symmetric encryptions. We talked about some of them, like CSI Aurora 13 and so on. Now, in this session, we will talk about the asymmetric encryptions. What do I mean and what does it mean in general? We will dive in. My name is Kurdo Jaza Mahmoud again, and we will start with the learning objectives first. Now, in case you have any question, as you can see my entire screen, I cannot see if you raised your hand or something. You can just open the mic and talk. Okay. And the first learning objective would be after studying the session, you should be able to explain the basic operation of asymmetric block encryption algorithms, then apply the asymmetric block encryption algorithms in variety of applications, presenting an overview of a digital signature mechanisms, and explain the concept of digital envelopes. Is there any question until now? Do you have any question about any of the learning objectives, Mr. Bahan? Yeah, sure. You're welcome. Now, uh, like an agenda or an outline for the cryptographic tools asymmetric encryption, we will first talk about the public key encryption, then digital signature and key management, then the practical applications encryption of stored data. Now, why do we need asymmetric encryption? You see, the problem with the symmetric encryption was the same key would be used for the encryption and decryption. However, that problem was you cannot share the key secretly, because in order to share the key you should share it through the internet, and the secret internet is not a secure place. Now, in Diffie-Hellman key exchange in 1976, he thought that what if we created two keys, one key only for encryption and one key only for decryption. That was the main idea of the asymmetric encryption, the idea of two keys. Think of it like this: you have a lock and have two keys. However, one key is only for closing the lock, and the other key is only for opening the lock. Now, the closing one would be a private, and the opening one would be public. Okay. Now, what do I mean by this? We will talk about in detail, and we will dive in. Now, the main idea is different keys, one for encryption, one for decryption. Now, confidentiality with asymmetric encryption, we have a public key encryption for the confidentiality, and of course using asymmetric encryption, because we had the symmetric encryption also, which it was the cryptographic tools. However, in here we have a public key encryption, we have symmetric block encryption algorithms, then stream cipher. Now, what is public key encryption? This is the topic. Now, public key encryption, we will talk about the structure, the application for a public key crypto system, requirements for a public key cryptography, and asymmetric encryption algorithm. Only for public key encryption, because the public key encryption is not like a simple topic. It has its own structure and has an own application requirement and its own algorithms. Now, the public key encryption structure is public and private key. Now, this would be the main topic, public key and private key. It is a pair of key, or let's say two keys that have been selected. So if one is used for encryption, the other used for decryption. By another word, we have two keys. one key would be only for encryption, one key would be only for decryption. Let's imagine if we used one key for both encryption and decryption, what will happen, Mr. Bowen? Yes, yes. hmm It is less secure and it will be called symmetric because we are using the same key. However, if we use two keys, we will call it asymmetric. Asymmetric. Okay, it is the name and the concept also. It's not only the name is changed, the entire concept will change because you see in here, as if you take a look at this figure, we have the plain text or the message. Whenever I say the plain text, I mean the message or the original message. Okay, however, in here we will present it as M. Now let's say that this girl want to send that boy from the right side, want to send him a message. In this case, when she want to send the message, she will encrypt it and she will create a ciphertext. So now we have a plain text. If we encrypted that plain text or that message, we will get a ciphertext. However, what is important for you to know is the encryption will use the public encryption key or the public key, as it is shown in here KB plus. Now, KB plus would be the public key encryption that will be used for encryption only. Now, let's see that this boy, let's say Bob, will get the message, and of course, he will not understand the message. He need to decrypt it for understanding. Now, in order to decrypt that algorithm or that message, sorry, he will use the private key. Now, you might say, well, what is this public key? What is this private key? Where they are stored? How this girl know which key to use and so on? We will dive in. We will talk about everything. However, we will for this one, it is only this. Now, let's say the steps of creating and using public keys. Now, each user generates a pair of keys to be used for encryption and decryption. What do I mean by this? I mean that this girl and this boy both they have a public key and a private key. Okay? Now, this each user places one of the two keys in a public register. Now, the public key, they will put it in some place and they say, everyone, anyone that tried to send me anything, please try this public key. You might say, well, the key is out there. How they can trust the process? The problem is it is like a simple door that can be only closed and locked with that key, cannot be opened. So even let's say a theft can have that key, he cannot use it. Now, this would be the public key. The companion key is kept private and the private key known as the only to its owner. Now, let's say that Mr. Bowan wants to create a public key and a private key. Now that you have a public key and a private key, the private would be only known by you. No one should know it. The public key, you will share it with me, with your friends, with anyone. You say that anyone wants to send me a message, please encrypt it using this key. Now I will try to send you a message and I will uh, encrypt my message, hello, Mr. Bawan, and I will encrypt it using your public key, your own public key, okay? And I will send you the message. Now, when you get the message, you should open it using your private key, okay? So this is the main idea. Now, what if someone will see the message? Let's say one of your friends, okay? Now, at that time, he cannot open it. Why? Because even if he know the public key, because it will not be opened by the public key, it will be opened by the private key that you have it and you did not share it with anyone ever. Now, we will explain it using another example. An user example, Bob can do the following. If Bob wishes to send a private message to Alice, so X let's say, want to send a private message to Y or to Z or to Y, let's say. In this case, Bob encrypt the message using Alice's public key. As I said, I will send you a message. I will use your public key. When Alice received the message, she decrypted using her private key. Now, in our example, me and you will use your private key in order to decrypt the message. No other recipient can decrypt the message. Why? Because the only Alice knows her private key. Now, if let's say Mr. Ahmed intercepted my message to you, Mr. Ahmed is between me and you. I send you a message. He will intercept it. He cannot understand anything because first of all, it is encrypted. Now, if he wanted to decrypt it, he doesn't have your private key because private key you never shared it with anyone, and there's no need for share it to anyone in the first place. So he cannot do anything. Now we have another thing. Let's say that Mr. Bawan want to send a public message. In this case, the public message for anyone or for any user, let's say, that now you will send the message and you will encrypt the message using your own private key. Now, anyone knows your public key can understand it. Why? Because your public key is out there and you can see it. Well, in this case, you might say, well, where's the security in here? Do you have that question, Saban? Well, what do you think? Now, you send a message, let's say to three friends. Okay, you will encrypt it using your own private key, and they can open it using your public key, which is in the public, in the internet, let's say. Now, where is the security of this process? What do you think, يعني? I mean, in your opinion, if anyone that can see, everyone can see your public key, and now everyone can see the message, so it will be decrypted if someone wants it. So where is the security in this? What do you think? Hmm. Hmm. He has no problem. Exactly. Let's say that the message is not important. Actually, the thing is in here is it is not the matter of security. Actually, it is the matter of security. However, as you said, Bob doesn't care about if everyone can see or cannot see. What is important in here is that anyone that can use the Bob's public key can understand the message and they will be 100% sure that Bob is the person that sent this message. So that is the basic, the main idea behind it. Okay, so let's say that I want to send a message on behalf of you. Okay, I don't have your private key to encrypt the message. And if I don't have, if I let's say used my own private key, and I will send it on behalf of you. And I say, let's say that Mr. Bowen sent this message. Anyone with your public key will try to decrypt the message. Now they see that the message has no meaning, and they will use my public key, let's say, and they see now the message makes sense. So it means that it was not from Bowen, it was from me. So no one can be pretending that it is you that's sending that message. It is like the authentication. Now, the public key cryptography, providing confidentiality, sending private messages, and providing authentication and data integrity. In our first example, we said that, uh, let's say I want to send you a message. Now, my plain text input would be my message. Hello, Mr. Bowen. This is my message. I will encrypt it using RSA, for example, and I will use Mr. Bowen's public key. Is that clear until now? Okay. Now I will send the ciphertext or the encrypted message. through internet, because I know even they if they got it, if they take the ciphertext, they cannot understand it and they cannot decrypt it. Why? Because in the decryption algorithm, and Mr. Bowen now, you will use your own private key to decrypt the message and to get the plain text. And that is the confidentiality, so no one can see the message. Now we have another mode, which is the providing authentication. It was the just the example that I talked to you about. Now, Mr. Bowen want to send a message to anyone. In this case, we have the your own private key. You will encrypt it using your own private key. Okay, and you will send it to me, to your friends, to anyone. Now, we will take a look at this repository that it is in here, and we see, well, this is, let's say, this is your key. This is your public key. We will try to decrypt it using this public key. If the message makes sense, it means that Mr. Bowen actually sent that message. Why? Because uh, he used his own private key. Now, if someone got your private key, which you should not be sharing it with anyone, if someone got your private key and encrypted the message with your own private key and shared it on behalf of you, and we will now use your public key to open the lock or open the message, at that time it would be a security flaw from you, Mr. Brown. So, because you shared your private key and no one needs your private key. Let's say you did not share it, someone stole it from you. Okay, so that time it would be your problem. So now the confidentiality for the encryption, we use the public key. Now for the providing authentication and data integrity, or data integrity can be an and or, we will use the encryption with the private key. And of course, the only person would move to encrypt the plain text with Bob's private key is Bob. Or Mr. Bound only can encrypt the plain text with your private key. Now, applications for public key, you might say, well, what is the importance of this and why do I need it? Because you believe it or not, this has been used like for a long time. Now, the digital signature is one of the examples. Symmetric key distribution, another example. Encryption secret of secret keys is another example also. Now, for the digital signature, what do I mean by this? Public key certificates or IPsec, TLS, or SSH. These they would use the this public key crypto system as their own application. Now, the symmetric key distribution would be Diffie-Hellman exchange. Now, for encryption of a secret keys would be digital envelopes. We will talk about what is the digital envelope, what is the Diffie-Hellman key exchange, and public key certificate also. Now, before explaining this, do you have any question? You're welcome. Now, how about my voice? Is it clear? Everything is clear? It's clear, okay. Now, we have the algorithms. We talked about the asymmetric encryption. We said that one of the topics would be public key and private key. We talked about it. Now we will talk about the asymmetric encryption algorithms. You see, we have Diffie-Hellman exchange, we have RSA, we have digital signature standard, DSS, we have elliptic curve cryptography, ECC. Now, hopefully, in our cryptography class, we will talk about in detail what is Diffie-Hellman, what is RSA, what is DSS, or what is ECC in general or in specific based on the course outline, the course information. Now, in here, we will just mention them. Okay, so you have a basic information, and when we reach the cryptography class, we will have the entire uh, information or the theory behind it or the math behind it. Now, Diffie-Hellman key exchange in 1976 or key agreement, the purpose of this algorithm is to enable two users to secretly reach an agreement about the shared secret key. that can be used as a secret key for a subsequent symmetric encryption messages. Now, Diffie-Hellman will be used in order to share a secret key between me and you. However, it should be securely. Okay, so Diffie-Hellman, I have a symmetric encryption, and I know that the symmetric encryption is not very strong. Why? Because every encryption is out there and anyone can understand it. And how does it work? However, the more important part is the key, not the encryption algorithm. Now, how to share this key? I need to use, let's say, symmetric encryption. I cannot work with the asymmetric. I don't have that knowledge, let's say. Now, I would say that, Mr. Bowen, we will use symmetric encryption. You say, well, I have no problem. However, how should we use the key, or what would be the key in the first place? I say, well, we will set a key and we will share it with the Diffie-Hellman key exchange. Okay, and let's see that how does the Diffie-Hellman works? I will explain it now. Now, first of all, neither me or you, we will not share anything. Okay, we will not share our key. That's for sure. Now, let me. Okay. Now, so how would I would do this? Now, let's say this is Alice, this is Bob. First of all, Alice and Bob says, well, we will uh, have a common paint. And this is a paint. This is not a number because paint is more, you can understand it more easily. However, it is for the same, even with the numbers. Now we will explain it with the paint. Now, Alice and Bob say that, well, we both say yellow. Now you might say, well, they will see yellow on the internet. Yes, they will say it on the internet. Anyone can see that the common paint is yellow. However, no one can see that what is their secret color. Now Alice's secret color is orange and Bob's is green. Let's say this is green. Now they will get what? Red, and they will get blue. They will share these two. Now, you might say, well, everyone knows that if we mix that yellow with the orange, it would be red. So the secret key is out there, or the secret color is out there. However, let's assume that the mixture separation is expensive. Okay, let's say that they cannot uh, separate what color would be red would be derived from yellow and which color. Let's assume, okay, because it is a color in here for explaining the topic, not the entire process would be just like this. It is a quite simple example. Now, once they shared the result with each other, so now they would also plus the same orange that they got with the with this one, and they will get the brown, and of course he did get the red, and he will plus it to his secret color, and he will get the also the brown. So this is how they would share something with each other, or the key with each other. Now, is there any question till now? Anything? Okay. Now, this was the Diffie-Hellman, and we have RSA, which is from the name Ron Rivest and Adi Shamir and Lynn Adelman at MIT 1977. They created this algorithm, and we will talk about it in cryptography class or in here even in the next slides. Now, what is the digital signature standards? In 1994, the NIST, the DSS uses an algorithm that designed to provide only the digital signature. It is unlike the RSA, cannot be used for encryption or key exchange. Now, the RSS can be used in order to encrypt a message or sharing a key or key exchange. However, the digital signature standard will only be used for digital signature. You might ask me, well, what is digital signature? I would say that it is just like your normal signature. However, this digital signature somehow cannot be forced, or no one can copy it and use it in order to send some data and says, well, Mr. Bowen sent this data. That cannot be happen, or is a very hard, very unlikely, or let's say to happen. Now we have another one of asymmetric encryption algorithms, or the last one would be elliptic curve cryptography. Now, ECC provide the same cryptography strength as a RSA system. If they asked you in exam, RSA and elliptic curve, they have the same strength as each other. You say, well, this is right. And they say that elliptic curve have a smaller key and it is faster than RSA. You say also that is correct. Okay, and a 256-bit ECC key is the same as 3072-bit of RSK. So in another word, if I used elliptic curve ECC with the key 256, it would be compared with RSA with the key 3072-bit RSA key. Okay, which is nearly which are 15% longer than the 248-bit key used in today's. Now, ECC reduces the processed overhead. Now, the RSA is the most widely accepted and implemented approach to public key encryption. And the RSA is a block cipher in which the plaintext and the ciphertext are integers between 0 and n minus 1 for some n. So the RSA will not take byte by byte or the bit by bit, let's say, sorry, bit by bit. However, they will take an entire block of the message. So if the message is hello world, so the hello would be one block, for example, and the world would be one block. So the RSA will take the hello entirely and try to encrypt it and then send you the ciphertext. Then the world encrypted, send you the ciphertext. In April of 1994, a group of working over internet using 60,000 computers or 1,600 computers claimed that the price after only 8 months of work this challenge using a public key size of 129 decimal digits or around 428 bits. So now they say that RSA is quite impossible to be cracked, and they at the first they put 129 digit or 200 for 428 bits for the key. Now after 8 months, it was actually I think a Siberian group of hacker. They claimed the price. They said, well, you can encrypt any message with this key, 428-bit key, and we can decrypt it. And it was actually correct. They did it after 8 months. Now, from that time and on, 124-bit key size, about 300 decimal digits, is considered strong enough for virtually all applications. Now, why? Because it is kind of uh, not that easy in order to crack the 124-bit key size. Now, we have the RSA algorithm. We said that we will talk about the RSA structure and the applications, and now we will talk about the RSA algorithm. Now, RSA makes extensive use of arithmetic operation using the modulo n arithmetic. Uh, can you remember what is the modes, Mr. Bowen? 19 mode 5 is equal to 4. Can you tell me why this happens and what does this means? No, I explained the modes in previous class of cryptography. If you can remember, we said that the 19 mode 5 is equal to 4. How did we got that 4? Can you remember? Okay. Anyone else? who's in here? I think someone else came. Mr. Muhammad, good morning. Just so you know, this entire class is being recorded, okay? And this class would be shared with you. It's okay. It's okay. I knew it. Now, Mr. Muhammad, do you know the mode? How did we got this? Okay, can you explain it for us? Mm-hmm. Thank you very much. Yes, it is correct. Now, Mr. Bowen, we said that when we have 19 mode 5, how would we know what is the mode? We say that we will put the 19 just like this, and we say that 5 would be in here. And we should multiply it by a number so it would reach this 19. We will multiply it by 3. Okay, so now it is 15. Now plus a number, plus a number. In this case, that number would be number 4. Okay, so 19 equal 15 plus 4. Is that correct? Is the basic math. I mean, nothing very fancy in here. So 19 is equal to this one. Now, this plus this number 4 would be our result. Okay, we will neglect this 3. We will neglect this 5. We will just think about the remainder. Okay, is that now, does it make sense? Okay. You see, guys, I have put a video about the cryptography or the math for cryptography. It is the session 2 of the cryptography class. I know this is computer security, however, uh, just a reminder, make sure to watch that video like 2 to 3 times, anytime that you feel comfortable with the algorithms or the techniques or the math that has been used in here. Because you see, that video, I have explained it all, nearly all the math that we will need it for cryptography. So, for example, today I will talk about some topics, and I cannot explain again what is the extended Euclidean algorithm. Maybe for mode it is 2 to 3 operation maximum. I can just do it fast. However, I cannot explain what is GCD again. What is the XGCD or extended GCD is. Please make sure to watch it, okay? Because you will need all of that. Now, the RSA algorithm uses mode a lot, okay? However, in this class, we will not dive into the technical or the mathematical side of it. However, you should know it, just even if it is like for your own information. Now, in the RSA, there are two interrelated components of the RSA. So we have two components that are quite related together. Now, and that would be the choice of a public key and a private key, and the encryption and decryption algorithm. So using the RSA, we would have the public key and private key and the encryption and decryption algorithm, because these are the two interrelated components of RSA. Not, it is not only for public key and private key, it's also for encryption and decryption. Now, the key generator algorithm would be just like this. Now, choose two large prime numbers. Now, what is the prime numbers? Can anyone tell me? Prime numbers are those numbers that can be divided by itself and number 1. So now in this case, I have 7. 7 can be divided by 7 and 7 can be divided by 1. There is no any other number in the world that you can divide 7 by it and get no fraction. Of course, you can divide it by 3, let's say, or 2, but you will have a fraction. And we said in cryptography or in these security related topics, we don't want any fraction. We want the integer numbers. Now, we'll say that the 5, and in this case, we will have, let's say that 5 and 7 or 7 and 9, it's totally up to you. Now we will compute n, and we say that the n is p multiplied by q. P would be 5, q would be 7, let's say. And z would be p minus 1 and q minus 1, or 5 minus 1 and 7 minus 1. Now choose a number e less than n. Now we have an n and we got a number. That's why you should always compute two large prime numbers. Why? Because if you just choose 5 and 7, you will get in this place and you see, for example, that number that you have in here would be the smallest prime number. So your key would not be that strong. And then has no common factor with z. It should be less than n and no common factors with z. Now, what is z? Z was in here, p minus 1, q minus 1. And then you would find the d in this process, and our public key would be n and e. You find the n in here and the e in here, and the private key would be n and d. Now again, n is in here, sorry, n would be in here, and d would be in here in this process. Now, we will not dive into the mathematical part of it as it is not required for this class. However, for the cryptography, if we need it, we will dive in deep. And of course, in the week 4 or 5, hopefully we will have it. Now, the encryption algorithm would be C is equal to m to the power of e mod n. Now, C would be the ciphertext, would be equal to what? The message to the power of E. You got the E in here, yeah. Mod N, and mod N, you know it. Now, in order to decrypt the message, you say my message that I will get it would be the ciphertext to the power of D mod N. Now, this would be the encryption and decryption algorithm part of it. Now, as our lab activity, or our first lab activity for this class, you should be doing this. We have a website which is devjalan.com online tools on the RSA encryption and decryption. First of all, you should create your pair of key. We said that we have a public key and we have a private key. Now you should share your public key with your classmate and keep your private key secret. Write a message and encrypt it using your own private key. Now share this message with your classmate and ask them to decrypt it using your public key. As we explained it, we know that we can do that, and it is for making sure that, for example, Bob is the person that sent this message, not anyone else. Now write another message and encrypt it using your friend's public key. Now share a message with your friend and ask them to decrypt it using his private key, and discuss the application of doing such activity. Now, Mr. Bowen, we explained it this one. Is that correct? Now, can you explain it for me? What do I mean by this entire process? Or let me, yeah, it was in here. Now, this is like a lab activity. Unfortunately, now we don't have any lab anymore. For these cases, we will try to create videos, and let's see when will the respected lab assistants will be available to create a video, and we will share it with you. However, it is quite easy. It is an online tool that you will only use it. Can you explain the first part, the encryption with the public key for me, or for your friends in general, I mean? Okay, okay. Mm-hmm. Okay, can you also explain the authentication? And yes, sorry. So you will be using your private key and you will send it to your friends. You say that this is the message that anyone can decrypt it. So now anyone can decrypt it. However, they will all know that it is from you. Why? Because your private key has been used. Okay, now Mr. Muhammad, do you have any question? Did you understand this? I mean, in this process? If you not, you could. Uh-huh. You got it. Okay. Now, this first one, you should do it, and if you had any question, you may ask me. Okay? It is only you visiting that website and create your own public key and private key. The website will generate it for you. You will just copy and paste it into a notebook. Now, once you did that, first of all, what you should do, write a message and encrypt it using your own private key. Once you do it, you would send your friends two things. You would say, well, this is my message and this is my public key. Can you decrypt it? When they will can, of course. However, they will know that only Mr. Muhammad can send this message, and it is actually from Mr. Muhammad. Why? Because they use his own public key. Mr. Muhammad is public key, and the public key and private key are connected to each other. If Mr. Muhammad is not the person that encrypted this message, they cannot open it with Mr. Muhammad's public key. Now, another one would be, for example, someone, let's say Mr. Bowen wants to send Mr. Muhammad a message, okay? And he will use your Mr. Muhammad's public key. Why? Because he wants to make sure that only Mr. Muhammad that has the private key will understand that message correctly. Now, this is the entire process of the lab, and it's quite simple. Let's let's click on it and do it ourselves. So you see, if you just click on it, it will take you here. I thought that someone came to the meeting. Who was it? Sorry. Do you know, guys? It's okay. It's okay, Mr. Bond. It's okay. Now, this is the website. What you guys need to do now, select the RSA key size. You could select 5.515 bit or 124 bit, to the 2048 bit, and so on. You can just choose, let's say, this one, and you would say, well, generate a pair of key for me. Now, this would be your public key, or this would be my public key. I will copy it, and let's say that in here, I would say a textbook. Now, I would say public key, PB. Now, this is my public key. I will save it, and now also I will have my private key. Now, for my private key, I will copy and I will put it in here, and I will not share this private key with anyone, because anyone that wants to send me an encrypted message can use my public key. So why do I need to use or share my private key? Now, let's say that I have a message. I say computer security class. Okay, computer. Now, what will I use? Enter a plain text to encrypt. Okay, I will put this one. Now, this would be my public key or my private key. I have this question. What should I use now? It says public key or a private key? guys. Yeah, I have a message and I want to encrypt it myself with my private key. Why? Ah, no, actually, uh-huh, yes, okay, confidentiality, yeah. Use publicly. Thank you very much, Mr. Muhammad. You see, that's why I asked you again at that time when Mr. Awan tried to explain the public key and the private key. That was it. Because you see, this is asymmetric class. The previous one was symmetric. We use only one key for public key and private key. We did not have like two keys. We only had the one key or one private key. For asymmetric, we will have two keys. Now, I want to make sure that everyone knows that this is from me, no, not from anyone else. Okay, I will use the private key and I will say encrypt. Now, the links tag too long. Yeah, expect it. I will use like 240, generate an RSA. I will copy it. Neglect the other part, guys, because as it is shown in here, it has a problem. Okay. هیچ کێشەیەکی نەبوو دوێنێ تاقم کردەوە. کێشەی نییە نا جێنەرێتی کیپەیرێکی ترم کرد بەڵام ئەمە ئەبێ خۆی بیکات ئەمە 2048 generate this and I will copy this and خۆی هێکسەر ڕاستەوخۆشی کاتە ئێراوە. Now ئەڵێم ئەمەم بۆ encrypt کا using this. Okay. You see what was the problem? I was saying that I have a computer security class. This is my plain text. And using this key encrypted. However, the key that has been provided was the private key, not the public key. That's why he could not encrypt the message. Okay. Now let's say that I will send this one, and now I have the encrypted, and I want to decrypt the message. Computer security class. قسەکە ئەوەیە کاتێک کە کلاس کاتێک کە تۆ ئەتەوێت بە public key encrypt بکەی مانای ئەوەی public key کەسێکت لایە ئەتەوێت بۆی encrypt بکەیت و بۆی بنێری بە private keyەکەی ئەو کەسی بەرامبەر بە private keyەکەی خۆی ئەیکاتەوە. ئێگە من بە private key خۆم تێکستێکم ئینکرپت کرد مانای ئەوەی ئەینێرم بۆ ئینتەرنێت لە ئینتەرنێتە هەر کەسێ پبلیکەکەی من کە خۆم شێرم کرد ئۆڕێدی ئەتوانێت بیبینێت و مەسچەکەش بکاتەوە بەڵام قسەکەوەی ئایا سکیوریتی تایە یاخودنا نا سکیوریتی بوونی نییە لەم شتەیە بەڵکو چی بوونی هەیە ئۆثنتیکیشن مانای ئەوەیە کە منم ئەو کەسێک کە ئەم تێکستەم نردووە کەسێکی تر نییە ینی هەدەفەکە لەوێ سکیوریتی نابێ بەڵکو ئۆثنتیکیشن نەبێ. Now, did you got the process, guys? Any question about this? So I have, yeah, sure. Now I have this, Mr. Muhammad. Yeah, you see, we have this topic. Where is it? Yeah, we have asymmetric encryption. And what do I mean by asymmetric? It means that I have two keys. One key would be used for encryption, and that key would be my public, the other opponent's public key. Now, in this case, we have this girl, we have this boy. This girl want to send a message to this boy. Clear until now? Okay. Now, this girl will use this boy's public key in order to encrypt the message. Now, she will send the message, and this boy using his own private key. that no one knows about it, will decrypt it. Why? Because these two keys are not the same. They are two different keys. However, the public key encryption is one of the advantages is you will not need to share your key. So the key sharing will not be a problem because you will not share it in the first place. Now, this guy will decrypt the message using his own private key. As you can see, this is the Baba's private key, and he will get the message. However, it is not only like that. Now, let's say that this boy wants to send a message to this girl or to anyone else in the internet. He will use his own private key. Private key خۆی بەکارەهێنێ and he will encrypt the message and send it to the internet. Now, this girl or anyone else in the internet can see this boy's public key and they can decrypt the message. Okay, so there's no security. Anyone can see it. Instead, there's something else. There's integrity. Now that I have used Bob's public key, I know that it is actually this message is from Bob. Why? Because I use his own public key. And well, everyone knows what is the public key. The problem is not the public key. Is the thing is the private key is only by Bob's side. Okay, so it is like this. We have the plain text. This is another example. I will be explaining again what do I mean by confidentiality and authentication, Kak Muhammad. Is it clear or still kind of ambiguous? Yes? Mm-hmm. No. Okay, this would be the job of cryptography class to tell you that we may have two different key, okay? One for encryption, one for decryption. However, they are not like each other. They are two different things. باشا اما ایشی الگوریتمەکانی RSA و جەماعەتی ئەسیمتریکەکانیان هێتە پێشەوە تێگەین ئێمە وتمان ئەسیمتریک واتە چی واتە دوو کلیلی جیاواز بۆ هەمان ئەلگۆریتم وایە زۆر باشە دەی دوو کلیلی جیاواز بۆ هەمان ئەلگۆریزم وەکوای بڵێ دەرگایەک بە کلیلێکدا ئاخرێ بە دەرگایەکەکرێتەوە بە کلیلێکەکرێتەوە ئێم شتە چۆن ڕوئەیە ئەمە بە قووەتی ئەو دەرگایە پیشانەیە مانای هەر لە هەمان شوێنی شۆ بۆ نمونە کلیلەکە بەیتە ناو دەرگاکەوە بەڵام ئەمە بە قووەتی شێوازی قوفڵکردنی دەرگاکە پیشانەیە ڕەحمەتت لێبێ ئەگەر ئینکریپتم کرد ناتوان پێی دیکریپت بکەم ئەمە قسەکەیە هەمان کلیل بەکار نایەت بۆ پرۆسەکەی پێچەوانی خۆی بۆنە کلیلی یەکم بەکارهێناوە بۆ ئینکریپشن بە کلیلی یەک ناتوانم دیکریپتی کەم و هەتا ئەگەر بشمەوێت ناتوانم ئەو شتە بکەم باشە جا we have two modes one for encryption the one that we talked about it now and one is for authentication now if I use my own private key and I encrypted a message, what will I have? I will have an encrypted message. Is that correct? Now you would send this message out there, and anyone that knows your public key, of course, let's say that your class they all know that what is your public key. They will get the message and they will decrypt it, and they will understand the message. The thing is in here there is no problem is no security. Okay, you don't care if anyone can see the message or not. You care about that they should know that it is from you ئەوان بزانن کە تۆ ناردووتە بۆ لەبرەی ئێمە وتمان کە ئەو کلیلەی کە پێی ئینکریپتەکرێت پێی دیکریپت ناکرێتەوە جا باش ئەگەر کاک محەممەد بێت بە پرایڤەت کیەکەی خۆی کە هیچ کەسێک نایزانێ مەسجێک ئینکریپت کە ئەینێرێتە بۆ منیان بە پبلیکیەکەی تۆ ئەیکەمەوە ئەم پبلیکی ئەو پرایڤەتکە کۆنێکتن بەیەکەوە ئەگەر کۆنێکت بەیەکەوە توانم دیکریپتیکەم مەسچەکە بینم ئەگەر نەمتوانی دیکریپتی بکەم نەتوانانی مەسچەکە بینم ئە لەویایە مۆسوعەکەیەتە پێشەوە مانای ئەوەی کە کاک محەممەد ئەسڵەن ئەم کەسنیە کە ئەم نامی نرد کەسێکی تر هەیە بۆ نمونە ئەوێ بە ناوی تۆ نامە بۆ من بنێرێ ئەو لەو کاتە ئۆثنتیکیشن و ئینتەگرێتی دەورە بینم Now, is it clear? Oh, you're welcome. You have no problem with it? Okay. So now in here, what did we do? We explained it this, okay? And guys, سعات دو یەک دقەیە ئێوە لە کلاسەکانتان بەم جۆرا بێ کاک محەممەدەر بۆ ئاگاداریت لە نۆ تاوەکو دە لە نۆ تاوەکو دە کلاسێکمانە بێ یاخود سێشنی یەکمانە بێ لە دە بۆ دە و سی ڕێستە لە دە و سی هەتاوەکو یانزە و سی ئەما بێتەوە بە سێشنی دووهەمی هەمان کلاس بەڵێ سێشنی دووەمی کمپیوتەر سکیۆریتی واتە کمپیوتەر سکیۆریتی لە 9 بۆ 11 و نیوە بێ بەڵام نیو سعات لەو بینیان ڕێستە بێ باشە اوكي بەڵێ بە تەقریبی بسێری کە کاک محەممەد طبعا من کێشەم نییە بە هیچ جۆری کێشەم نییە بەڵام یەکەم شت ئەم ڕێستە بۆ ئیسراحەتی ئێوەیە بۆ تێگەیشتنی ئێوەیە بەگشتی بۆی شتەکان هەکەڵەکە نەبن بەسەرێکا و باس بکرێن دووهەم شتیش ئەم سێشنانە ئەبێ لە کاتی خۆیانە بەرگوز ینی دەست پێ بکرێن و ستارت و ئەندەکەیە بێ بۆ جۆرەوە کە تایمتێبڵەکە دانراوە لەبەرەوەی لەلایانی زانکۆشەوە چێکی ئەم شتانان کرێتەوە ئایا بەپی تایمتێبڵەکە کلاسەکان ئەڕوا یاخودنا لەبەرەوەی ێستا بەڕێزت کێشەت نییە باشە بەڵام بەگشتی زانکۆ بۆ ئەم شتەی داناوە بۆی هەمووان کێشیان نەبێسە لەم کلاسە کە دوو کەسە لەوانەیە کێشەنەوە بەڵام بەگشتی هەموو کلاسەکان بتێنە توێ تەلەبەکان تااقەتیان نابێت سعات و نییە بەسەرێکەوە هەر کلاسەر کلاسەر کلاس جا لەبەرەوە ئەیکەین یان ئەتوانین وەکو احتیاطێک ئەتوانین ڕێستەکەتان کەن بە چارێکی ئەگەر ویستان تۆتەلی ئەپتیو ئێوە خۆتان نیو سعاتی قانونیتان هەیە ئەتوان بیکەم بە چارێکی بووی زووتر لە بنەوە تۆتەلی ئەپتیو ئەگەر هەموو تەلەبەکان ینی هەر هەمووان بێگومان ێستا کرد کاک باوانە بەڵام ئەگەر لەگەڵ هەمووانە قسە بکرێت و هەمان کێشیان نەبێ بکرێت بە چارێکێک ئەو کاتە لەگە مسەرشیا با قساکەین نۆڵین کاکە ئەوان خوێندکاران خۆیان داوای چارێکێکەکەن بەڵام ئەگەر هەمووی ڕازی بێ یەک کەسیش ڕازی نەبێ هەرە بینی و ساعتەکە بێ I know he sent me a message هەر خۆشی نامێکی بۆ ناردن باسی سیچویشنەکەی کرد دەسە خۆش بێ بەڵام مەبەستم لەم نیو سعاتەیە جا ئەم نیو سعاتێ سەمە 4 دقەمان لە کاتی ئەوە خواردووە بەداوای لە برنۆ ناتوانم 4 دقەکەتان بەمەوە چونکە ئەمە کاتی ئەمە کلاسم شەرح نەکردو بەس بۆی کە بزانن بەو جۆرا بێ تەواو تەواو ئۆکەی ئینشاءالله لە دە و نیوە we will return back ئۆکەی دەستی ئێوەش خۆش بێ و لەشتان ساغ بێ هەرە خواتان لەگەڵ بێ Now, welcome back. We will start with second session of our class, computer security class, and yes. Now, can you see my screen? No problem? Okay, okay. So you see, guys, we explained in this lab activity how to go to the RS encryption or decryption website and how to create a pair of key. One of them would be the public key, one of them is the private key. We explained it, and it was in here. First of all, we generate the key, then we will save these two key in our site. The public key has no problem. You can share it with anyone that you want. However, the private key should be only by your site. And then you can encrypt and decrypt using these keys that you created right now. Now, this was our plain text. We said that I want to encrypt this message using my own public key, or let's say in this case one of my friends' public key, okay, because I want to send him a message and I will use his public key to encrypt this message. Why? Because I want to make sure that he will be the only person that can decrypt this message. So I encrypted it and I sent this message to my friend. Now my friend, what will he do? He will just copy and paste the ciphertext that he got. He will put it in here, and of course, let's say that this part has nothing. This would be my friend's private key. He will paste his private key in here and says, well, this is private key and I want to decrypt it. And you will touch the decrypt and he will get the computer security class message. Now, this was our first lab activity. or our first activity to say. Now, we have something else. We have public key encryption. There's something PGP, or Pretty Good Privacy. It is a company, let's say, that enables a user to generate a key from a password and then use that key to encrypt selected files on a hard disk. Now, what would we use would be the Cleopatra. There's a software named Cleopatra. It will take some time to open. From this link, you can download Cleopatra. Just one click on it and you are good to go. Yeah, this JPG for Win 502, you can download it. And once you download the file, you come to here. I already created my own public and private key. You will also create your own keys. And then once you did it, you can use uh, these tools, the sign or encrypt or decrypt and verify. However, in order to sign or encrypt a message, you should have the persons that you send the message his own public key. Now, if you wanted to decrypt or verify, for the decryption, the person needs to be using your own public key so that you can use your private key to decrypt or verify. As we said that, I want to make sure that it is actually from my friend. Any question, guys? In case you have a question, it is totally okay to have questions. However, I want you to use this software. It is like 5 steps only. First of all, he will ask you for a name and then he will create your public and a private key. You should back up as it is written in here. I want you to do this. Create a new key pair. It is step by step. It is not nothing like you should go to there and there. You should create a new key pair. Share your public key with class or with one of your friends. Let's say Kak Muhammad, you will create his public key with one of his friends. And if the most important would be make a backup of your keys. So if you lost it for that account, you cannot use any other keys. And then import the public key of your classmate into Cleopatra. If you had, let's say, Mr. Bounce public key, you should import it to the software, and it is nothing like very uh, tricky or hard to find. It is in here. Import the certificate from a file or export or certify. It's very easy. It's only these. Now, once you did that, you can encrypt and decrypt the messages. However, I want you to do this. Okay, this lab activity is 100% just like this lab activity. However, in here, we used this website and we generated the public key and the private key in the same website and we encrypted, decrypted in the same website and the same page. However, this one used the Cleopatra software. So I want you to use this, and if you had any problems, it's totally okay. You can send me an email or in the WhatsApp group, you can share your issue, and I will be more than happy to help. Now we have something else. Create secure SSH login. Now this is a lab activity that I will do it for you. Okay. You might ask, well, what is the SSH? You gotta know it by now. SSH and Telnet. You know what is SSH and Telnet and the difference between each one. Is that correct? Yeah, Kak Muhammad, can you explain it? What is the SSH or why do I need it? And what is the Telnet? Why do I need it? Uh-huh. Okay. Okay. For remote control. Okay. 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 Hmm. Okay. So let's say that I have a server. Yeah, thank you very much. That's totally correct. Thank you. Let's say that I have a server and it is in Kirkuk. Now, my company tells me in 2 in the morning, okay, they call me and they say, well, that server is down. You gotta do something with it. Well, I say, what is the problem? Well, they say some users complains that they cannot access what and what. Okay, you know the rest, the technical stuff. Well, in your home at 2 in the morning, okay, at 2 a.m., you cannot just say, well, I'll fire up my car and I'll go to Kirkuk only for checking if the server has a problem or not. What you do, you would do use SSH login. Why? As Mkag Muhammad explained, that Telnet is not secure and it is not recommended to use. It was the first versions of remotely accessing something. Now we have SSH, it is more secure and we can use it. Of course, we have no problem. So once I open up my computer, I will try to use SSH and I will log into that server, check the overall properties of my server. Let's say that is there a problem with the RAM or is there a problem with the hard disk and so on. Now this would be the SSH. Okay, SSH by default will use a very secure algorithm. However, there's something else we can use the public key and a private key for it also. We explained the public key and a private key. In the rest, I done with my GitHub account. Okay, now I will explain in here and then we will come to the PowerShell. Now use Windows PowerShell to create a public key pairs. First of all, you will create your public key pairs, your public key and your private key. Now, how to do that? You would type SSH keygen and SSH keygen command to create a new pair. Yeah, you can do that, and you can give it the hyphen T for this algorithm instead of RSA or ECDCA or DSA and so on. And the minus B would be for the key size. Okay, so the main job of the keygen or the SSH key generator will be to create a public key pairs. Now, once we did that, we can securely open GitHub on my command shell and make sure that in between me and GitHub, if there's someone intercepted my communication, it would be secured. Is it like uh, is it clear till now? Okay, so now how to do that? You'll come to the PowerShell and you will just type power in the start. Sorry, PowerShell, and this would be the PowerShell. Once you open the PowerShell, the first of all, what you need to do is type SSH keygen. Okay, SSH keygen. Now you gotta be aware of the spelling and the hyphen and everything. It is not underscore, it's a hyphen, so you gotta be aware of it. Now, if you just did this question mark and enter, it would tell you all the uh, arguments that you can give to SSH keygen. Okay, I think you know about this and you use already Linux, Ubuntu Linux, I think in operating system. So you gotta know this. So it would be by another word, I can give minus A for the rounds, minus B for the bits, minus C for a comment, minus F for the output key file, and so on. Whatever comes to your mind. Now, what will I do? I will just erase this and I would say SSH keygen. However, with minus B or hyphen B, not minus, I will not say minus anymore, so you are not conflicted. With the hyphen B, I set I set the key size bit to 1496. Okay, and with the minus T or the hyphen T, I set the as it is in here, selecting encryption algorithm, I set the encryption algorithm to 80 25519. Now, once you touch enter, it will give you the pair of keys. Now, because I already put my GitHub, I already copied my public key to GitHub, so I don't want to generate it again. However, we will do it if it was necessary. Now you come to your GitHub, you will have something like this. Now let me come to the users home SSH. Now it will come to here. Now you see I have two keys. Now this would be my public key. How would I know? If I right click on it and came to this, you see here is .pub, the public. Now let's look inside it. Let's see what is inside it. You have this. I don't know if you can see it. Yeah, you have this. And it will tell that this is the computer I want to verify and so on. Now also this would be my other key. Now open with notepad. Now this beginning of a SSH private key. This should be on my side. I will not share with anyone and no need even for the SSH. Now I will copy the content of this one, Control A, Control C, and I'll come to GitHub. In GitHub, come to setting. In setting, come to SSH and JPG keys. Once you touch it, I already did. Okay, now let's say that you want to do it again. New SSH, paste it in here, name it whatever you want, and add SSH key. Okay, well, now Mr. Bowen might say, well, why do I need to do this? Why do I need to, in the first place, why should I do this? I will ask you, what if you wanted to access Git from here, from using SSH? Okay, how will you do that? You will do it this way. Now, through SSH, you will access GitHub, and you should get this. Hi, Kurdo Jaza Mahmoud, you've successfully authenticated, but GitHub does not provide shell access. So now the problem is with the GitHub, not with me. Okay, because I already secured all of my connections. Now, if I wanted to access it through the another CLI, I'll be able to use it with SSH, not using the GUI. Okay. لبري ما زانی لە دنیای لینکسە زۆربەی شەکان بە شەڵ ئەکرێ نەک بە GUI. Now this was this. First of all, we created a SSH keygen with this algorithm and with this bit of the key size, and then we used the public key we copied the public key into the GitHub, and we use the private key, or the computer actually used the private key in order to authenticate. Guys, do you have any question? Barazankas Keshi here. Was it clear? So you have no problem. You understand the process. Okay, thank you very much. Now we have explained it. This activity and this activity. Now your job would be to do this activity, and it is only installing Cleopatra, creating a new pair of key, and then have your friend's public key encrypt. You're using your friend's public key, and he will be able to decrypt the message using his own private key. Now this would be the process. Digital signature and key management. You see, the digital signature ensures that the signature are verified, authenticated, and legitimate. Now we will talk about why in the first place, why do I need a digital signature? Now the application of a public key algorithms would be these. Public key algorithms are used in a variety of applications. These applications falls into two categories. either digital signature or key management and distribution. Now, this is the not like the main this would be the main usage, however, not only usages. Now, with the respect of to key management and distribution, there are at least three distinct aspects of use in a public key encryption in this regard. First of all, or the first point that you should be aware of it 100% is to secure the distribution of a public key. Now, the use of public key encryption to distribute secret key. The third one would be the use of a public key encryption to create temporary key for message encryption. Now, somehow this one is new. Okay, we will try to talk about it. Now, the applications for public key crypto systems would be digital signature. Digital signature mechanism for verifying the origin of authentication. We said that sometime no problem if anyone can see the message. However, I want to make sure that it is actually from Mr. Bawan that I got that message. That would be the origin authentication. It means that make sure that Mr. Bawan did send me this message. Now we have some algorithms: RSA, Diffie-Hellman, DSS, and elliptic curve. These algorithms, RSA would be used for digital signature, for symmetric key distribution, or an encryption of a secret key. What are these three? They are at this point. Okay, now RSA will give me all of these. That's why you may hear RSA a lot. Now, Diffie-Hellman will not give me a digital signature, and it would give me symmetric key distribution and encryption of a secret key. DSS would only give me the digital signature. Elliptic curve would give me digital signature, symmetric key, and encryption of a secret key. Well, you may ask me why I hear about RSA a lot, but not with elliptic curve. Elliptic curve is quite powerful. However, there's one simple problem with it. It said the message size is, if message size is 1 GB, the key size also need to be 1 GB. That would be a disaster. That would need a lot of computation power in order to encrypt a message, let alone the decryption part of it. That's why RSA is strong and we can use it compared with the elliptic curve. Now we have a digital signature. Let me, yes. This is Bob. This is Alice. Bob want to send a message. Okay, what this person do? Uh, First of all, he will create the cryptographic hash function of the message. Now we have the H or the hash. With the original message also comes here, and this hash digital signature generation algorithm will be using the digital signature algorithm. We will fed it this hash and we will have the signature. Now if I asked you how can I create a signature, you would say, well, I have my own message, I will use one of the algorithm to create the hash of my message, and then from another algorithm that will be created for digital signature generation, or it will generate for me the digital signature, I'll give it that hash, and now I have my signature. Is that clear? أمرونا وتم مسجك هاشك ورا أجرم أو هاشي كورم قرتوا أيام با algoritmێکی تر بۆ ئەوەی جێنەرەیتی digital signature بۆ بکە بەڵام بە private keyەکەی خۆم، not with anyone else's private key, with my own private key. Now I have my signature. I will send the message and I will have my signature. Now, what about Alice? Okay, Alice would do this process again. Now she get the message with the signature. She want to make sure, is this Bob really? Does Bob send me this message? And he says that let's say that I want to break up with you, or someone else. Okay, she want to make sure she will have the message with the signature. Now the message she will also create the hash of the message, because you see that the hash will not change. Okay, the hash is the hash of the message, no problem. And if the hash is changed, actually in this step also you can see. However, Bob did not give her the hash. That's why she cannot see. Just imagine that Bob sent a message with the hash, and she will not even do the sign in anything. She will just hash the message again and will compare the two hashes and see that if the message was tampered. Now, in this case, no, it is only signing. So she will generate the hash and she will take the signature and give it to what? To digital signature verification algorithm. Because in here we have the generation algorithm. Now in here we have a verification algorithm using the Bob's public key, because we know that this is private key of Bob and it will be in here. Now this would be the public key of Bob and it is out there for anyone. She will use this public key and return the signature valid or not valid. Now, this process would tell us that this signature is valid or not. By another word, does Bob actually send the breakup message or not? That would be the job of a digital signature. Now, we explained it in using this uh, diagram. However, in here it says the public key encryption can be used for the authentication with technique known as a digital signature, or this one. The digital signature provides a mechanism for verifying origin, authentication, data integrity, and signatory non-repudiation. Now, digital signature algorithms. We have digital signature algorithm DSA, the original NIST approved algorithm, which is based on the difficulty of computing discrete algorithms. RSA digital signature algorithm based on a RSA public key algorithm. Elliptic curve signatory algorithm EDSA based on elliptic curve cryptography. Now we have a digital signature example. And for this, use Cleopatra. Again, you can use also Cleopatra for this. Or for practicing the digital signature. Bob want to send a message to Alice. Again, Bob and Alice. Bob is a boy, Alice is a girl. Bob want to send and wants Alice to be certain that the message is indeed from him. Now, let's say I want to make sure that I would send a message for Mr. Muhammad, and I want to make sure that it is actually from me, not from someone else's. Now, Bob used the secure hash function such as SHA-512, and the SHA stands for Secure Hash Algorithm 512 to generate a hash value for the message. And then Bob used the private key to encrypt the hash signatory using the digital signature of generation algorithm. It is actually this this one. Okay, so that slide explain again this one. However, with text بتكست بس يا كلام جارة. Bob مسجي هي هاشك دروسك أو هاشش بم public بprivate كي خوي generation signature generation algorithm بكارينه بويكا signature بخوي دروسك. Bob used his private key to encrypt the signature using the digital signature generation algorithm. Sorry. Now Bob sent the message with the signature attached. Alice received the message plus the signature. So she will get the message and the signature. Now she first will do this. Calculate the hash value for the message. Then provide the hash value and a Bob's public key input for digital signature verification algorithm. If algorithm returns the result that the signature is valid, Alice is assured that the message is indeed been signed by Bob. Now, this is the text, and the previous slide was the illustration example explanation. Now, before explaining the public key certificates, who has a problem or there a topic that you did not understand, guys? Yeah, sure. Okay. آه باشا. باشا. طبعا. طبعا ئەوە یەک ئەوە طبعا یەکێکە لە شێوازەکانی دیجیتال سیگنیچر باشە. با بڵێن تۆ کەسێکی زۆر گرنگی تر بە مۆزوعی سکیوریتی خۆتی هەز هەڵبەتە ئێستا لە دنیای ئەمڕۆمانە بۆ نە وەتسا بەکارێنی وەتسا بڵێ end to end encryption نازانمەگەرم مەسجت بینی بە end to end encryption ینی بە فولی هەمووی ئینکریپت دەکرێت بەڵام لە دنیای ئستەخباراتیە باوەڕیان بە هیچ شتێک نییە باشە و باوەڕیش بۆ ناکەن کە بڵێ مەڵای کاک محەممەد کاکەەوە من سوفتورێکم دروست کردووە و من سکیورم کردو بۆ برا تۆ عزل مکێش و هیچ شتێمەکە ئەسڵەن هەر باوەڕی پێ ناکەن بە قسەکان باشە جا لە برۆ خۆیانیان چی ئەەکەن ئەمانە بەکارەهێنن بەڵێ ئەکرێت یەکێک لە ڕێگاکان ئەوە بێ بەڵام ڕێگەی تریشی زۆرەی چێک لەوانە کلیۆپاترای کە زۆر بەڕوونی ئەتوانی هەر شتێکت بۆ هەو ئۆریجنەکەی چەکەیتەوە سیگنیچەر بۆ چییە سیگنیچەر نامەکە شەنێریت سیگنیچەرەکە شەنێری نامەکەش کێ سێرێگا با سەریکا قسەکە ئەوەیە کە ئایا ئەم نامەی هەر بەڕاستی لە لای منەوە هاتووە بۆ لای تۆ یاخودنا ینی ئەمە this is the main idea سەلامت بیم و ئەوەی کە بەڕێزت باست کرد بەڵێ یەکێکە لە ڕێگا سادەکان یەکێکە لە ڕێگا سادەکان کە بەکارهێنرێ Now, Mr. Bound, do you have any problem? You're welcome, friend. Now, the public key certificate. Forging. What does forging means? Do you know, guys? The word forge. Forge yani saxtakirdin. I knew that you may not understand it, so that's why. So now anyone can forge a public announcement. بۆ نمونە لە نامەیەک دانراوە دەربارەی شاری سلێمانی و ئەم نامەی وا دانراوە کە ئەڵێن بەڕێز دکتۆر هەواڵە و بەکردینەوە ئەگەر وانە بچی باش ێستا لە دنیای سوۆسیال میدیام هەواڵانە بینی ئێستاوای لە تۆ کەس نازانی باوەڕ بەچی بکەیت okay the public key certificate بۆ نمونە لەم حاڵەتەیە بەکارێنرێ و ئەمە چۆن بڵێ ئەمە ئایدیاکەیەتی نەک ڕێگەوەی کە بێ پۆستێکی سوۆسیال میدیا و بۆ چێکاتۆ کە ئەخۆوایەوە نییە بەڵکو ئەمە ئایدیاکەیەتی کە بۆ نەگە شتێک دانرا یاخۆ شتێک نێررا بۆمە 100% دڵنیامەوە کە بەڵێ ڕێک ئەو کەسە نەردەینەوە Now, you see, anyone can forge a public announcement that some user could pretend to be the Bob to send a public key to another participant or broadcast such a public key. Now, anyone can say that my name is Mr. Muhammad Kamal and this is my public key. However, they thought about this and they tried to prevent this. Now, the solution to this problem is the public key certificate. In essence, a certificate consists of a public key plus a user ID of that key owner. The whole block signed by a trusted third party. Now, I will explain it this way. Okay, it is for explanation. There might be some information here not 100% correct. For explanation, so you get the big picture. Now, Mr. Muhammad Kamal wants to make sure that he will create his own public key and a private key, and it is actually him. Now, Mr. Bawan want to send a message for Mr. Muhammad Kamal, and he want a total encryption. First of all, he want to make sure is this really Mr. Muhammad Kamal or not. Uh, now, Mr. Muhammad Kamal need to do some job. Okay. Now, what you would do, you will create your private key and public key. You will take your public key and your ID. Your ID, let's say your passport. You will take it to a company. Okay, name is trustee. For example, I have that company. My name is trustee. My company name is trustee. You will bring me your passport with your public key. Okay, now my company certificate authority, okay, that is trusted by the user community such as government agency or a financial institution. Now, a user can present his or her public key to the authority to secure manner and obtain signed certificate. Now, Mr. Muhammad Kamal gave me his passport, his public key. I will give him what? A signed certificate. Okay, I will give him a signed certificate. Now, the user can publish the certificate. Anyone needing this user's public key obtain the certificate and verify it is valid by means of the attached trusted signature. Now, I will, sorry, could you explain? The main picture, yes. However, I have a company name, let's say Dulniai. My company's name is Dulniai. What will I give you? I will give you a certificate. Okay. So now you would come to my company. You say, Mr. Kurdo, this is my public key and this is my ID, my passport, to know that actually my name is Muhammad Kamal because my picture is here and this is my name and you can take a look and this is me actually. I want to create my public key. So no one else will use another public key and says, "Well, I thought that this is Muhammad Kamal. There's 20 Muhammad Kamal. How should I know which one is this?" And so on. I say, "Well, okay, give me your passport and give me your public key. In one day, I will give you back a certificate." شهادة تيمم. Now, in a place that you put your public key, you will also put your certificate. You say that Dulniai company give me this certificate that this is actually Mr. Muhammad Kamal, let's say Ahmed, with this name, with this age, and so on. Now this would be a certificate. أما شهادة كبيرة كبلة بلام للاني شوا certificate authority وهذا منهم كومباني من certificate authority به وبك سكي سقى بكراج من كومباني شي لعبة لعبة وهم روشة وجبي شت تزوير كاتو تيتاقينا بالروح. Okay. Now, did you got the point? Mhm. Mr. Bowen, understand? No problem. You're welcome. You're welcome. You're welcome. Now, public key certificate. Okay, we explained it. However, this is something else. Now, why would I say something else? Now, I would tell you. Bob's ID information, or let's say Mr. Muhammad's ID information, passport, with the public key, with the CA information. Okay, these whole would be created a hash. Now we have a hash of all of these three. Okay, then this hash, generated hash code or an assigned certificate, would be signed using what? Using the generated digital signature using CA's private key. Okay, now I have my message and I have signed the certificate. Now for the other part, use a certificate to verify Bob's public key. I have the Bob ID information. I have the Bob's public key. I have the CA information, and I'll create the hash. Now I will verify the digital signature using CA's public key. Now I return the signature valid or not. This will give me if it is valid or not. Okay, so this is the process of public key certificate. Now we have something else. We have a digital envelopes. Creation of a digital envelope. This is envelope. كاغذينامة. We call it envelope. We have something. We have the message. We will encrypt the message using what? A random symmetric key. And we will put the encrypted message inside this envelope. However, using this random symmetric key, we will encrypt the receiver's public key also. Okay. How? I have, let's say, someone that I want to send them a message. Ahmed. I want to send a message to Ahmed. Now I have the public key of Ahmed. Okay, I will use the public key of Ahmed to encrypt the key, the random symmetric key, and I will give that encrypted symmetric key inside the digital envelope. Now, anyone can intercept this. Anyone can take this. However, because I have used the public key of Mr. Ahmed, only Mr. Ahmed can decrypt it, the key. I have the key, but no usage. There's no usage of that. It's another way. Okay, you may ask me, well, why in the first place should I put the this key in here? I can just encrypt the message using Ahmed's public key and then sending it. Well, yes. However, this is also another technique that they have used it for some time, and it can be used. Now, digital envelope, opening digital envelope. Now, Mr. Ahmed got the digital envelope. He got the encrypted message and he got the encrypted symmetric key. He will decrypt the message using the random symmetric key. However, in order to get the random symmetric key, Mr. Ahmed will decrypt that key with his own private key. Once he opened the key, he will give the key to his friend, and then let's say to his wife, and wife will be able to decrypt the entire message. Now, this is digital envelope. Do you have any question about the securing and opening? 100%. Yeah, yeah, sure, sure. 100%. I have my friend, Mr. Bawan. I have Mr. Bawan as my friend. I want to send you a message. Okay, Mr. Bawan, what will I do? First, I will encrypt my message using a very random key. Okay? And using your public key, I will encrypt that key. And I will send you the message. مسج يكم هي انكريبتي أكم بتشي انكريبتي أكم بكليلك راندوم وكليلكش انكريبت أكم بتشي ببابليك شيكي تو اسكا تواو كليلك انكريبتو مسكش انكريبتو اينيرم باشا اي چۆن ئەی کاتمەوە بۆ ئێستا مستەر باوان ئەڵێ باشەوە من ێستا مەسجێکم هاتوتە بەردەست مەسجێکی ئینکریپتی تایە و کلیلێکی ئینکریپتی تایە چی لێکم ئەڵێم decrypt the key with your private key. Okay, now you will get the random symmetric key, and from that key you can open the encrypted message. Is it clear? You're welcome, guys. Is it clear? Okay, now Mr. Muhammad Kamal, is it clear? You're welcome. Now the reading topics would be application of a public key encryption, symmetric key exchange using public key encryption, digital envelope, and the use of random numbers for public key. When did we talk about this, the use of random numbers for public key? It was in here, random symmetric key. It was random, okay? And we use the public key of the receiver to encrypt it. Now, our next session would be user authentication, okay? چۆن authenticate user بکەین چۆن دڵنیابینەوە کە user خۆیت یا خۆی نییە. We know by now we have two-factor authentication, we have email recovery, and we have mobile phone in our Gmails, let's say. However, we will talk about the user authentication in general, and we will dive into some part of it also. Now, any question؟ يا ما عنديش برسالة ثانية. You will, you're welcome. ئەگەر هیچ پرسیارێکتان نییە وەلا هەموو شتێک تێگەیشتون ئەتوانین سەیسراحەتی خۆتان وەربگرن و ئەگەر ویستان ئەتوانین لە 4 بۆ 12 بینەوە یاخود سعات 12. Okay. Now, Mr. Bowen, we will start at 12. دروستە دروستە هیوادارین کە تەلەوەکانی ترەوە نەجددی بن وەکو بەڕێسان بێنەوە بۆ کلاسەکە بەڵام سعات 12 ڕێک تەواوکەین. Okay. ئێستا سعات 12 دەست پێکەینەوە. Okay. And any question ئەگەر پرسیار نییەوە ئەگەر هەموو شتێک تێگەیشتن now you may leave. No question. Okay, guys. You're welcome, guys. And inshallah, at 12, we will